In the heart of Putrajaya, the Federal Administrative Center of Malaysia, stands a building that is one of its kind. The Diamond Building, the headquarters of the Energy Commission. The Diamond Building, located in Precinct 2, Putrajaya, was conceptualized to be a landmark building, both in terms of architecture and sustainability. The diamond shape symbolizes transparency and integrity, which reflects the Energy Commission's approach in regulating the energy sector in Malaysia. From a distance, the building shines like a diamond, pioneering the new concept of a modern building. It showcases technologies that substantially reduces energy and water consumption, harness sustainable building materials, and provide an enhanced indoor environmental quality.
The idea of the diamond form was first conceptualized after a thorough study and visits to nearby countries like Japan, Thailand and Singapore, which has started to look into low-energy buildings. The diamond form is unique and prominent. It symbolizes value, quality, and transparency.
The four key elements of the building design concept are 1. Energy efficiency, 2. Water efficiency, 3. Environmental protection, and 4. Indoor environmental quality.
We are proud to showcase this green and sustainable building that sets the standards for the future.
The Diamond Building is targeted to reduce energy usage by 65%, with a building energy index of 85 kilowatt-hour per square meter per year at 2,800 hour usage. The average building energy index of a normal office building in Malaysia. The diamond shape, with its 25-degree tilting facade, becomes self-shading, avoiding direct sun rays entering into the building. Tilting facade also results in smaller building footprint, which allows for more landscaping, thus reducing heat gain into the building. Using low E glazing that is reflective on the outside allows daylight into the building and minimizes heat gain from the sun. In addition, the reflection by the white ceiling and wall surfaces propagate daylight into the office area. Mirror light shelves and fixed reflector blinds are installed for glare control and to provide a glare-free and visually pleasant daylit environment for the occupants. Manually operated roller blinds are provided for the lower part of the window. The unique design of the atrium enables natural daylight to be utilized for the office areas. The dome is equipped with automated blinds and comprises of 6 different configurations to maintain the appropriate daylighting levels at all times. The window sizes become larger as one goes deeper into the atrium to cater for lower daylight levels. A band of Tenenbaum reflector panels are applied to the 4th and 5th floor to deflect daylight across the atrium to the 1st and 2nd floors, where daylight levels are at the lowest. The stacked profile reflectors have an inclination of 10 degrees and reflect about 85% of the light in semi-diffused manner, hence avoiding visual glare for the building occupants. The light trowel on the 7th floor gives the lounge area a unique ambience. The indirect daylight drawn from the roof channeled to the lounge area below makes it bright as though being lighted. The use of high-efficiency lighting systems such as compact fluorescent lights, T5 fluorescent tube with electronic ballast, and LED lights is part of the design strategies to enhance building energy performance. This reduces the lighting power consumption by approximately 50% as compared to conventional design without compromising its brightness. Light sensors placed throughout the building ensure that the electrical lights only are switched on when daylight levels are insufficient. Individual task lights also reduce energy for lighting, as this permits a lower set point for the general lighting. To reduce energy consumptions throughout the office, only energy-efficient labeled equipment are used. This contributes to achieving the building energy index through reducing the plug load's energy consumption. Air conditioning for the building is provided by two separate systems, the radiant cooling slab system and the conventional cold air supply system. The radiant cooling slabs have chilled water pipes embedded in the concrete slab itself. Cold water is run in these pipes at night time to cool the building slab down to 18 degrees Celsius. These slabs will radiate cooling to the occupants of the building to provide comfort at room temperature of 24 degrees Celsius. The advantage of such system is it will lower energy consumption as water has higher heat transfer rate than air, while the pump is typically more efficient than fan, therefore reducing the energy used to transport cooling around the building. The radiant cooling slab system needs to be complemented with a significantly downsized conventional cold air supply system to ensure that the environment is kept dry to prevent condensation on the chilled slab and also to provide adequate fresh air to the building occupants. For the hot water system in the building, the drained water from the showers runs through a heat exchanger technology using coiled copper pipe that recuperates 35% of the heat. The heat is transferred to the incoming cold water combined with a solar hot water installation, hence reducing the energy for hot water. One of the energy-efficient car part technologies is to use jet fans as a replacement for a conventional ducted supply and exhaust fan system. To reduce the operational time of the jet fans, natural ventilation openings are introduced into the car park on each side of the building, including a sunken garden at basement 1, linking directly to the car park. The diamond shape of the building helps funnel air through the car park. Carbon monoxide sensors are installed to ensure that the jet fans only operate when the carbon monoxide level exceeds 25 parts per million. The diamond building also promotes the use of renewable energy. Photovoltaic panels are integrated as part of the building design to harness solar energy. The total installed photovoltaic capacity is 71.4 kilowatt peak, which feeds directly to the national grid. The thin film solar panels have been measured to have an annual yield of 1,400 kilowatt hour peak, and they cover about 10% of the building's energy consumption. Water efficiency is part of the key elements in the design of this building. Choosing water-efficient equipment such as dual flush toilets, waterless urinals, and water taps with aerators have proven to be practical. Rainwater is harvested and stored in 4 rooftop rainwater tanks. The rainwater is then used for toilet flushing and irrigation. Recycling is one of the major concepts applied in this building, including the recycling of water usage. Grey water from wash basins is used to irrigate mini wetlands that are part of the ground-level landscape. A green landscape can provide better working environment to the occupants, as it also provides a cool and shaded ambient environment. Indoor materials with low volatile organic compound content, such as paints and carpets, are selected to minimize health risks. Most of the workstation materials are green labeled, which means it is made from recycled materials. The rooftop features 7 key green elements of the building. They are 1. Building integrated photovoltaic panels. 2. Dome and shutter. 3. Rainwater harvesting. 4. Roof light trowel. 5. Greeneries on the roof. 6. Insulated concrete roof. 7. Floor slab cooling.
These features present the ideal building concept, which is energy efficient, water efficient, and eco-friendly, which enhance the indoor environment for the comfort of the occupants of the building.
The diamond building is designed to create a pleasant, healthy, and comfortable working environment. From the dome to the courtyard, All considerations have been taken into account. The Energy Commission building has received Platinum certification, the highest rating for both Malaysia's Green Building Index and Green Mark of Singapore.
The government has implemented energy efficiency initiatives in the building sector, starting with the ministry's LEO building and the Malaysian Green Technology Corporation GEO building. The Energy Commission Diamond building was completed and equipped with energy efficiency characteristics and low carbon released structures. These initiatives are in line with the government's commitment to reduce the release of greenhouse gases and assist in addressing climate change issue.
A true form of art, a diamond in the heart of Putrajaya. The Energy Commission building is the symbol of an ideal building, setting the standard for the path to a more sustainable future. Diamond Building, a gem in Putrajaya.